Alright, welcome to Unit 5.1. Yeah! Unit 5 is all about systems of equations. Systems of equations is the idea that you can graph a line and then another line and you figure out where the two systems, where they intersect, right? So systems of equations is all about finding the location of intersection. Right? Systems of equations. Two or more equations. With the same variables. So in our case, both equations will have an x and a y, which means we can graph them, right? As an x and a y. All right? Graphically, the answer, the solution to the system of equations is the point where x and y, where they intersect. The point where they intersect, the point where they cross. Right? Algebraically, the solution is the point that makes both equations true. Right? So you have to have a point that makes both equations true for it to be a solution. That's why they intersect, because it's a point where it's true for both equations, right? So, intersecting lines, right? Suppose you have two lines and they're like this, right? The solution is right there where they intersect, right? That's your solution. There will be one solution if they are intersecting lines. One solution. It'll be a some value of x and some value of y. It'll have one solution. Alright? Now, parallel lines are the ones that ride side by side and they never intersect. There is no solution. Right? There is no solution. That's your zero with a line through it. There is no point where they will intersect. They're parallel. Right? And then you have the same line. So suppose you have a line and you graph it, and then you have another line and it's the same exact line. They're on top of each other. Right? This is infinite solutions, or infinity. I have to figure out how to write the infinity symbol again. I know, good luck with that. Alright? If I go too fast, rewind it, watch it again. If it's still too fast, rewind it, slow it down, and watch it again. You're welcome to turn on the closed captioning, that should work. You should also be able to translate it into Spanish on the closed captioning, so that might help. Alright? So, solve systems by graphing. This is one way to solve systems of equations. This is one way to find the point, the solution, right? This is how we do it when we're graphing, right? Step one, rewrite the equations in slope-intercept form. Intercept form. Right? Rewrite them in y equals mx plus b. That's why we focused on that so hard. If the equation is not in y equals mx plus b, we have to convert it. If it's halfway there, we need to finish converting it. If it's out of order, we need to put it back in order. Right? Step two, graph the line. Graph the line using b, right? And then m, slope. Use your y-intercept and then use your slope. And then 3, identify the solution or solutions. Identify the solution or solutions if it's infinity, right? Identify where do they intersect. Where do they intersect? That's your question. We're graphing them to find out where they intersect. Solve each system of equations by graphing. All right, I'll do the odd, you do the even. I want to go too big. All right. So, both of these are already in y equals mx plus b. Step 1. Step 2, graph the lines. This is our b's, these are our m's. So, my first equation, the slope is 1, which is 1 over 1, has to be a fraction, and the b is negative 8, right? So I'm going to graph this first at negative 8. 1, 2, 3, 4, 5, 6, 7, 8. It's good. Negative 8, so I went down 8. Rise over run. And my slope is 1 over 1, so I'm going to go up 1, right 1, up 1, right 1. And because we're doing two different equations and we're trying to figure out where they intersect, it's smart to go ahead and graph as many points as you can, because you don't know which one is your solution, right? So up and right, graph as many points as you can. Down and left, left, right? That's my first line. I'm going to draw my attempted straight line. That's not bad. All right, now my second line. My m is negative 2, which is negative 2 over 1. And my b is positive 1. So I'm going to go up 1 on the y-axis. And I'm going to put my first point. Positive 1, up 1. This is directions to my next point. I'm going to go down 2, and I know that that's the right direction because it's going to intersect. Right? So if it was telling me to go up, I would have to go the other direction. Remember, equivalent fractions to go the opposite direction. Down 2, right 1. Down 2, right 1. Down 2, right 1. Down 2, right 1. Whoa! That right there, where they're on top of each other. Bam! That's my solution. Right? So, I'm going to finish graphing my lines. You have to graph the lines. I have to be able to see them intersect. Right? Alright, so now I just have to figure out what this is. So it's the origin, positive 1, positive 2, positive 3. So we know it's 3, comma. Origin, down 1, down 2, down 3, down 4. We went, no, that's not right. Down 1, 2, 3, 4, 5. We went down 5. Right? So that is my solution. That is where the lines will intersect. We're trying to figure out, using a graph, where the lines are going to intersect. Alright, the first thing I notice is that they are not in slope-intercept form. They're in standard form. I have to convert them. Alright, so I'll start with the first one. Negative 3x plus y equals 8. I need to isolate the y. It's a negative 3x, so I'm going to add 3x. I can't combine these because they're not like terms. So I bring it down. Y equals 3x. It's a positive 8. Don't forget the positive sign. Now it's in slope-intercept form. So my m is 3 over 1, and my b is positive 8. Alright, second equation. Negative x plus y equals negative 2. Put the invisible ones if you think it'll help. Right? Put the invisible ones if you think it'll help. Again, isolate the y. It's a negative 1x, so we're going to add 1x. That's going to leave me with y equals 1x minus 2, because this is a negative 2. That means that my slope is 1 over 1, and my b is a negative 2. Now I just need to graph them. This one's first point is at positive 8. On the y-axis, 1, 2, 3, 4, 5, 6, 7, 8. And this is directions to my next one. I already know I'm going to have to use an equivalent because I need it to go the other direction. To make an equivalent fraction, change both signs. Change the numerator and change the denominator. Right now they're both positive. So to make an equivalent fraction, I make them both negative. Down 3, left 1. Down 3, left 1. Now you see why I taught you how to put more points than 2 and why I taught you equivalent fractions. I knew you were going to need them. Down 3, left 1. Down 3, left 1. Whew. Alright, that's all it's going to fit. So that's what I'm going to go with. Oh, that's not even close. Oh, that's better. Not perfect, but better. Alright, second line. First point, my y-intercept goes on the y-axis at -2. Origin, -1, -2. The origin is 0. Always remember that. The origin is 0, 0. My directions are up 1, right 1. If I go up 1, right 1, it's not going to intersect in this direction. I have to go the other direction. So instead of 1 over 1, the equivalent would be -1 over -1. Down 1, left 1. This might intersect. This is looking more possible. Oh, bam, right there. Alright, so I'm going to draw my line. Not bad. This point right there where they intersect is my answer, my solution. And that is -1, -2, -3, -4. Let's try again. -1, -2, -3, -4, -5. So it's -5 for x. And then -1, -2, 3, 4, 5, 6, 7. -7 for y. You have to write it like coordinates because that is the solution. That is where the two lines are going to cross. Alright, one of these is already in an interesting form, right? Good thing we learned how to graph vertical and horizontal lines. Right? This one should be easy. Y at -7, so on the y-axis, 1, 2, 3, 4, 5, 6, 7 down. Y at -7. Right? And we know, because it's just y equals -7, that it's going to create a horizontal line. That's an easy one to do. Right? And then the next one, it's not in slope-intercept form. So we need to convert it. It's a positive x, so we're going to subtract x. Put the invisible ones because it will help you. That leaves you with 3y equals -1x minus 15 because that's a -15. Alright, we're going to divide by the 3 to get rid of the coefficient. Now you see why that invisible 1 helps you. Because you might get confused and think it's -3x. It's not. It's -1 over 3x. Right? Y equals -1 over 3x minus 5. This is why we simplify. Alright, first point at -5. 1, 2, 3, 4, 5 on the y-axis. Down 1, right 3. Down 1, right 3. Down 1, right 3. Bam! That's where they intersect. Right? And the point where they intersect is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. -7. +6, -7. Because I went right 6 and down 7. Remember, if I'm going too fast, then you need to rewind and watch it again, slow it down, watch it again, turn on the closed captioning. Both of these need to be converted. So that's where I'm going to start. 3x minus 5y. The first thing you should ask yourself is this in slope-intercept form? If it's not, What do I need to do to get it to slope intercept-form? I'm going to subtract 3x. Leaves me with negative 5y equals negative 3x minus 35. Divide by negative 5. Y equals 3 over 5x plus 7. I'll go ahead and graph it. 1, 2, 3, 4, 5, 6, positive 7 means go up. Up 3, right 5. Or the equivalent, down 3, left 5. How do you know if you did the right equivalent fraction? It makes a line. If it's not a line, you did something wrong, because we're making linear equations. We're graphing linear equations, lines. They have to be lines or they're not linear equations, period. Alright, other one. 2x plus y equals a negative 6. Subtract 2x from both sides. Y equals a negative 2x minus 6. So we're going to go down 6. 1, 2, 3, 4, 5, 6 on the y-axis. And then we're going to go down 2, right 1. But that's not going to take us in the right direction. So again, all you have to do to create an equivalent